Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for October-November 2022. So let's get started. Question 1 says a wire is approximately 48 centimeters long and has approximate diameter of 0.30. Question 1 says a wire is approximately 48 centimeters long and has an approximate diameter of 0.3 millimeters. Which measuring instrument can be used to obtain a more precise value for the dimensions of the wire? So the length of the wire, we can't use 30 centimeter rule. Half rule, yes. Micrometer, yes, for a wire. Micrometer, yes, for a wire. So the answer is C. Question 2 says the velocity time graph for a car is shown. What is the distance traveled by the car in 35 seconds? So we need the area under this graph. So we can divide it into different areas. So we have here a triangle, then we have a large rectangle and another triangle. So for this part we have half multiplied by base, which is 10, multiplied by height, which is also 10. So it gives an answer of 50. For the rectangle we have the base from 10 to 35, that's 25, multiplied by the height, which is 10. That gives an answer of 250. And for the triangle on top, we have half multiplied by 10 from 25 to 35, then multiplied by the height from 10 to 20, that's 10. So that gives 50. So we have a total of 350 meters. So the answer is B. Question 3 says which property of a body results from the effect of gravitational field on its mass? So the effect of a gravitational field is attraction force, which is the weight. So the answer is D. Question 4 says the diagram shows 4 pieces of laboratory apparatus. We have balance, measuring cylinder, ruler, and a stopwatch. Which pieces of apparatus are used to find the density of the liquid? So we need mass and volume. For a liquid we need a measuring cylinder. So balance and stopwatch, no. Balance and measuring cylinder, yes. So the answer is B. Question 5 says a metal rod of length 80 centimeters is pivoted at point O. Its center of mass is at its midpoint. 4 pulley wheels are indicated by the letter P. The rod is in equilibrium, so it does not move. So the tension from this wire and this wire must balance the weight of the rule. What is the weight of the rod? So we have here 0.10 kilograms and 0.10 kilograms pulling down. So the total pull from the ropes is equal to the weight. So we have 2 multiplied by the weight of the blocks. So 0.10 multiplied by 9.8. That gives an answer of 1.96 newtons. Pull from the ropes, that is equal to the weight of the rod. So the approximate value is 2 newtons. So the answer is C. Question 6 says the diagram shows an object moving at constant speed in a circular path in the direction shown. A force acts on the object to keep it in a circle. So the direction of the force or the resultant force on an object moving in a circle with constant speed should always be towards the center. So the answer is D. Question 7 says a force F acts on a body of mass m for a time t. During this time, the velocity of the body increases from u to v. Which equation relates F, m, t, u, and v? So we have the equation that force is equal to the rate of change of momentum. So it is equal to m v minus u over t. For these choices, we have this one makes sense. So if we bring the time to the other side by multiplication, we get ft is equal to m multiplied by v minus u. So the answer is C. That is the equation for impulse or the change in momentum. Question 8 says an object falls toward the Earth's surface. What happens to the gravitational potential energy and the kinetic energy of the object? So an object falls, that causes a decrease in potential energy and an increase in kinetic energy since it will be speeding up. So the answer is B. Question 9 says a skier is pulled up a short straight slope at constant speed by a rope. The tension in the rope is 100 newtons and there is a combined friction and air resistance force of 20 newtons. Acting on the skier, the slope is 10 meters long and the skier rises 1.5 meters vertically. How much work is done by the rope? So we need the force in the rope and the distance traveled in the direction of the rope. So work is equal to the force multiplied by the distance. So we have 100 newtons multiplied by the distance 10 meters. So the answer is 1000 joules. So the answer is C. Question 10 says, in some situations a force does work. Which set of conditions increases the quantity of work done? So the magnitude of force either increases or stays the same, not decreases. Distance moved by the force stays the same or increases, not decreases. So the answer is C. Question 11 says, a measuring cylinder of cross-sectional area 4 cm squared contains 224 cm cubed of liquid. The pressure of the liquid at the base of the measuring cylinder due to the liquid is 8,800 Pascal. What is the density of the liquid? So we can use the equation pressure equals density multiplied by gravity acceleration multiplied by depth, rho gh. But if we try that, we find that the density and the depth are not known. So we can use the other equation, pressure equals force over area, in this case weight over area. We have here mg divided by area, and we can substitute m by density multiplied by volume, then g divided by area. So we have 8,800 Pascal is equal to the density unknown multiplied by the volume, which is 224, then by gravity acceleration, which is 9.8, over the area, which is 4 cm squared. Then we multiply by 4 on the other side, and we divide by this bracket on the other side. But first we need to convert to SI units, since all the answers are in kilograms and meter cubed. So the volume would be times 10 to the power of -6, and the area would be times 10 to the power of -4, from centimeter cubed to meter cubed, and from centimeter squared to meter squared. That gives an answer for the density of 1603.5. So the approximate value is 1600 kilograms per meter cubed. So the answer is C. Question 12 says, the pressure of a fixed mass of gas in a cylinder is measured. The volume of the gas in the cylinder is slowly decreased. The temperature of the gas does not change. Which graph shows how the pressure of the gas changes during this process? So as you decrease volume, pressure increases, but it does not start from zero. It starts from an original value, then increases as volume decreases. So the answer is C. Question 13 says, which statement about evaporation is correct? A body in contact with an evaporating liquid loses thermal energy. Yes, because the molecules of the liquid need to absorb heat to evaporate or to break intermolecular forces and escape. A decrease in the surface area of an evaporating liquid increases the rate of evaporation. No. A wind over the liquid increases the rate of evaporation. No. It is necessary to provide external source of thermal energy. No, you don't need external source of energy to evaporate something. So the answer is A. Question 14 is about thermometers, so you can skip this for the new syllabus. Which change in the design of a liquid in glass thermometer makes it more sensitive? So a larger liquid reservoir, yes. A longer tube, no, that increases the range. A smaller liquid reservoir, no. A wider tube, that decreases sensitivity, not increases. So the answer is A. Question 15 is about latent heat capacity, so you can skip that also for the new syllabus. It says an ice cube of mass 12 grams at 0 degrees Celsius absorbs thermal energy from the surroundings at a rate of 3 joules per second. That's power. The specific latent heat of fusion of ice is 330 joules per gram. How long will it take for the ice cube to melt? So we can use Q equals ml, or power multiplied by time is equal to ml. So time is equal to ml over power. So we have the 12 grams multiplied by the 330 joules per gram. We have to make sure that the units for mass is the same, over the power, which is 3. So the answer is B. Question 16 says, which piece of equipment is designed to produce a type of electromagnetic wave? We have electric fire, electric generator, electric motor, electromagnet. So an electromagnet does not create electromagnetic waves. Electric motor creates motion, generator creates electric current. So the electric fire is the option because it produces infrared radiation, which is a heat radiation. Question 17 says, a passing boat causes a floating object on a lake to bob up and down 18 times in 12 seconds. The wavelength of the wave created by the boat is 48 centimeters. What is the velocity of these water waves? So velocity of a wave is equal to the wavelength multiplied by the frequency, and the frequency is calculated as number of waves over time. So we can calculate that as 48 times 18 over 12. That gives an answer of 72 centimeters per second, since the wavelength was in centimeters, so the answer is B. Question 18 says wavefronts are incident on a boundary. What is needed for the wave to refract at the boundary? A shiny surface at the boundary, a small gap in the boundary that causes diffraction, different mediums either side of the boundary in which the frequency of the wave is different. Not frequency, it is speed of wave is different, so the answer is D. Question 19 says a person uses a magnifying glass to look at a stamp. Which ray diagram shows the thin converging lens being used to do this as a magnifying glass? So the rays must diverge so that their extensions meet behind, because a magnifying glass is used when the image is virtual, so the answer is A. Question 20 says the diagram shows an object in front of a plane mirror at which labeled position is the image of the object formed. So the object is here, the image is right in front of the object at the same distance, so the answer is B. Question 21 says the diagram shows the action of a thin converging lens on two rays of light. The rays are from the top of an object O, an inverted image I is formed. Which name is given to the distance RS from the optical center to the focal points, that is the focal length, so the answer is C. Question 22 says the diagram shows the air molecules in part of a sound wave at a particular moment in time. Which statement is not correct? Earlier there was a compression at X. Yes, since the compressions and rarefactions move along this direction because the vibration is horizontal in this case. Later there will be a rarefaction at X. Yes, also. This part of the wave is traveling horizontally across the page. Yes, it's either moving to the right or to the left. This part of the wave is traveling towards the top of the page. No, because the vibration in a longitudinal wave is parallel to the direction of the travel of the wave, so the answer is C. Question 23 says the speed of light in vacuum is 3 times 10 to the power of 8 meters per second. Which value is closest to the speed of light in air? So the speed of light in air is almost the same as the speed of light in vacuum, so the same number, so the answer is D. Question 24 says a 100-meter race is started by firing a gun. The gun makes a bang and a puff of smoke at the same time, so that's sound and light. When does the finishing judge see the smoke and when does he hear the bang? So see the smoke almost immediately because the speed of light is very high, and hears a bang after about 0.3 seconds, much later than light because sound is much slower than light, so the answer is B. Question 25 says a student is to demagnetize a bar magnet. She tries 4 different ways. Hammering the magnet, that would work. Heating the magnet works also. Passing direct current through the magnet, that does not make anything. Placing the magnet in water, no also. So which methods will demagnetize the magnet? Only 1 and 2, so the answer is B. Question 26 says a student is investigating a resistance wire. She measures the current in a 50 centimeter length of resistance wire. The student repeats the experiment using 100 centimeter length of the same resistance wire. What is the effect of this change on the current in the circuit and on the resistance of the wire? So the resistance increases as length increases, so it's either B or D, and the current in the circuit decreases when resistance increases, so it's A or B, so the common answer is B. Question 27 says a resistor is connected to a cell so that there is a current from the positive terminal of the cell to the negative terminal. What causes the current in this resistor? Electrons move from the negative terminal to the positive terminal, that is correct. Electrons move from the positive terminal to the negative terminal, no. Protons move, that's not correct, so the answer is A. Question 28 says a plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. Which statement is correct? Electrons move from the cloth to the rod, that's not correct. Electrons move from the rod to the cloth, yes, because the rod becomes positively charged, so it loses electrons to the cloth, so the answer is B. Protons do not move inside the material. Question 29 says which combination of the current in a resistor and the time for which it is present results in a charge of 240 coulombs passing through the resistor. So a current of 2 ampere 120 seconds, 4 ampere 960 seconds, 6 amperes and 14 minutes. 8 amperes and 30 minutes. So we need to multiply current by time to calculate charge. So the first one, 2 times 120 seconds, that would give the answer of 240. So this is the one. So the answer is A. Question 30 says each potential divider is placed in a circuit with a power supply. Which potential divider makes the potential difference across component Y increase when light intensity increases? So we do not need thermistors, so it's not C nor D. So let's see, when light intensity increases, the resistance of an LDR decreases and the voltage across it will decrease, but we need the potential difference across Y to increase. So if we see the first choice, so here voltage decreases, so the voltage across the other component, which is a resistor, increases, which is Y, so this is the answer. If we try the other one, Y will have the lower voltage, and that's not the required in the question, so the answer is A. Question 31 says two resistors R1 and R2 are connected in series in a circuit as shown. The current in resistors is I0. Another resistor R3 is then connected in parallel with R2 as shown. How do the currents I1 and I2 in the resistor R1 and R2 compare to I0? So if we add another resistor in parallel, the total resistance actually decreases. So the current coming from the battery increases. So I1 would be greater than I0. And then we have this part of the circuit has a lower resistance, which means it takes lower voltage. So a lower voltage on a fixed resistor creates a lower current. So I2 would be less than I0. So the answer is D. Question 32 says the diagram shows a circuit containing a cell, a lamp, and 2 ammeters. The current reading on ammeter 2 is 0.20 amperes. What is the name of this type of circuit and what is the reading on ammeter 1? So this is only one loop, there are no branches here, so it is a series connection. And in a series connection, all currents are the same at every section of the circuit, so it's 0.20 amperes, so the answer is A. Question 33 is about logic gates, so you can skip this for the new syllabus. The diagram shows how logic gates can be used to monitor the temperature in a refrigerator. So we have a magnetic switch on and off, closed 1, open 0, temperature sensor cold 1, hot 0, main system switch on 1, off 0. So the warning light will come on if the output Z is 1, the door R is open, temperature sensor is cold, and the main system switch T is on. What is the logic state at Y, and is the warning on or off, meaning 1 or 0? So for door R open, we have a 0 entering here, so we have here 1. For temperature sensor cooled, that's 1 entering, so we have here 0. 1 and 0 to an OR gate, that gives 1, so the answer at Y is 1. And the main system switch T is on, so that's 1 entering here, so we have 1 and 1 to an AND gate, that gives 1, so the warning is on, so the answer is D. Question 34 says 4 small compasses are placed around the solenoid. A current is now switched on in the solenoid. Which diagram shows possible new directions of the compass needles in the diagrams? So the first two are wrong, since the compass should point horizontally. Since there would be a magnetic field line pointing this way, it's either right or left, not pointing towards the solenoid. So it's either C or D. But we need to use the right hand grip rule to know the direction of the magnetic field. So for a current going this way, up from the front and down from the back, we use the right hand grip rule to curl our fingers in the direction of the current. The magnetic field is actually pointing to the left, so the compasses right next to the solenoid should point to the left, so the answer is D. Question 35 says which metal is used for the core of a transformer? A core of a transformer uses soft iron. Question 36 says the diagram shows a conducting metal rod PQ in the magnetic field between the N pole and the S pole. The rod is connected to a resistor in a circuit. In which direction should rod PQ be moved to induce a current in the direction of the arrow in the circuit? So if we consider the magnetic field pointing to the right and the current pointing into the page. We can use the right hand rule to predict the direction of the motion. So the middle finger is pointing into the page, the index finger to the right with the magnetic field, the thumb is pointing upwards. So the answer is A. Question 37 says a thin metal foil is placed in a vacuum. Alpha particles are fired at the foil and most go straight through. A very small portion of the alpha particles are deflected through large angles. What does this provide evidence for? Alpha particles are very small, that's not relevant. There are negative electrons, you cannot know that from this experiment. There is a tiny nucleus in each atom, yes, tiny because a very small portion only hit that nucleus. There are neutrons in each atom, no, because neutrons are neutral and cannot affect anything. So the answer is C. Question 38 says the table compares alpha, beta, and gamma radiation. Which row is correct? Alpha more ionizing than beta, that's correct. Less ionizing than beta, no. More ionizing than beta and gamma, yes, correct. For beta radiation, it is a proton, no. It is an electron, yes. An electron, yes. Electromagnetic radiation, no. Gamma radiation, electromagnetic radiation, yes. 2 protons and 2 neutrons, no, that's alpha. Electromagnetic radiation, yes. It's a proton, no. So the common is C. Question 39 says a high voltage power supply is connected to a metal grid and a wire as shown. When the radioactive source is placed close to the grid, sparks are observed in the position indicated. Which statement explains why the sparks are formed? Alpha particles have a long range. No, that's not correct. Alpha particles have no charge. They do. Alpha particles have no mass. They do. Alpha particles are strongly ionizing. Yes, because they have a high charge. So the answer is D. Question 40 says the student investigates 4 different radioactive isotopes. The student places a detector near each radioactive material. The background count is 36 counts per minute throughout the investigation. The table shows the detector readings at the start and after 8 hours. Which isotope has a half-life of 4 hours? So it should decrease by half twice, but we do have background, so it's harder than you would expect. So for choice A, the initial reading was 150. We need to subtract the background radiation, that gives 114. So we have 114 divided by 2, that gives 57. Divided by 2 again for 2 half-lives, that's 28.5. Then we add 36 back for the background. That gives 64.5, which is not the answer here. So it's not A. For B, 212 minus 36, that gives an answer of 176. 176 divided by 2, that's 88. Divided by 2 again for the second half-life, that's 44. Then we add 36, that gives an answer of 124, which is not the answer again. For C, we have 260 minus 36, that gives an answer of 224. 224 divided by 2, that gives 112. Divided by 2 again, that's 56. Then we add 36, that gives an answer of 92. So this is the correct answer, so it is C. And this was the end of the exam. I hope you enjoyed this video and it was useful to you, and I will see you in another video.